Hi, thanks for watching. This is Mr. Bowen, and in this video we're going to talk with you about direct and joint variation. So let's talk about direct variation first. We say that y varies directly as x if there is a non-zero constant k, right here k, such that y equals k times x. We call that k the constant of variation. You actually spent a lot of time in middle school studying situations of direct variation. And what you learned in your studies in middle school is that we often, when we talk in Algebra 1, call that constant of variation in this situation the slope. But that constant is a different constant in every one of these scenarios. One interpretation of what that means is this: as one of the quantities increases, if I were to increase x, what would have to happen to y? Well, y would have to get bigger as well. And the same is true if I were to change y and increase y, then x would have to increase as well. As one quantity increases, the other increases as well. And you could replace the words increases there with decreases and still get a true statement. So there are a lot of examples of direct variation situations. If we were spending a little bit more time together in the classroom, we would dig a lot deeper into this than we get to with the setup we've got. Here's simply one example of that scenario. Here's an example of direct variation: the number of miles you drive your car and the amount you spend on fuel. The more miles you drive your car, the more you're going to spend on fuel. If you increase the amount you're spending on fuel, presumably you've increased the amount you've driven your car, and vice versa. As one increases, so does the other. So here's an example of the type of problem we would hope that you could use direct variation to solve. It says that if y varies directly as x, that's a key phrase to pick out there. And I'll go back and talk about that with you when I'm done reading this sentence. But if y varies directly as x, and y equals 9 when x equals 6, that's important as well. What do I want you to find? It says find y when x equals 8. So the fact that it says y varies directly as x tells you you can use that equation from the last screen. Y equals kx, where k is that constant of variation. Now, what this red part here tells you, when y equals 9 when x is 6, it tells you values you can plug in for x and y to find k. So let's do that. Let's let y be 9, and let's let x be 6. And if 9 equals k times 6, you could divide both sides by 6 and get that k is 9/6. And in Algebra 2 Honors, I'm hoping you're going to call that 3/2. So now you've got k, and you can use it to find the y they're asking for in the problem. It says find y when x equals 8. So if you go back and write the variation equation, but you know that k is 3/2, you can find y when x is 8. Let k be 3/2, and let x be 8. 3/2 of 8. Well, 3 times 8 is 24, and 24 divided by 2 is 12. What value does y have when x is 8? It's 12. Okay, so here's an example of joint variation. We say that y varies directly as x and z if there is a non-zero constant k such that y equals k times x times z. Simply what this means is that an increase in either x or z will cause the same effect on y. Keeping one of those, either x or z, the same, changing simply one of them will have that same effect on y. Okay? So joint variation, joint meaning together, it means that x and z both can change the value of y. So let's look at a joint variation example and try to piece it together the same way we did the direct variation example. This one says if y varies directly as both x and z, that's still important, it tells you which equation to use, and it says that y is 10 when x is 2 and z is 4. Find y when x is 4 and z is 3. So this first statement is super important. It tells me that I can use the equation y equals k x z. That's the joint variation equation. The red information here tells me information I need to find k. When y is 10 and x is 2 and z is 4, what is k? Well, let's figure it out. 10 would be k times, that's 8, isn't it? So if 10 equals 8 times k, k is 10 divided by 8, which I hope you will write as 5/4. And then can we use that information to find y when x is 4 and z is 3? Sure we can. Because if y is k times x times z, we know what k is. And we know what x and z are supposed to be. 5/4 times 4, that's just 5. So 5 times 3, how about y equals 15? Thanks for watching.